welcome all of you to this event today. For the library, this event represents one of our presentations in Research in Progress, which is the series that we've put together to track faculty and invite you to come and talk about your research in progress, particularly research that's related to some of the AU 2030 projects, and this one certainly meets that definition. But it's also about a consortium within this university that's been put together, which is do you pronounce it the Ecollaborative? Yes, the Ecollaborative Colloquium on Climate Change. We worked really hard to get all of that alliteration in there. So today's event, sponsored by the library and by this colloquium, is going to showcase the research, the interdisciplinary and innovative research that's being done within the collaborative. We have four scholars today from the university who will center their discussion on issues concerning climate change. I'm going to introduce each of the panelists, talk a little bit about their presentation, and then I will get out of their way. Dr. Rebecca Dell is adjunct professor in the College of Arts and Sciences. Her topic today is ocean turbulence and climate. And Dell's presentation looks in detail at the physics of mixing and turbulence in today's ocean and the ocean of the last ice age. Her research reveals some interesting surprises about how the ocean works. Dr. Dell is a former research fellow at the Scripps Institution of Oceanography in San Diego, California, and now works at the Domestic Energy Policy Office of the U.S. Department of Energy, in addition to being an adjunct faculty member here at AU. She received her PhD in climate science and physical oceanography from MIT and the Woods Hole Oceanographic Institution. Daniel Fiorino is Distinguished Executive in Residence in the School of Public Affairs. His topic is climate change in action in the United States. Why is it so difficult, and what are the prospects? Intonation was mine. Mr. Fiorino will discuss explanations for why progress in climate change policy has been difficult at the national level and the prospects for future action in the next decade. He is the director of the Center for Environmental Policy and executive in residence in the School of Public Affairs. As a faculty member in the Department of Public Administration and Policy, he teaches courses on environmental policy, energy and climate change, environmental sustainability, and public management. He is the author or co-author of 4 books and some 36 articles and book chapters in his field. He received his PhD and MA in political science from Johns Hopkins University and his bachelor's in political science and a minor in economics from Youngstown State University. Dr. Sakina Jinnah is assistant professor in the School of International Service, Global Climate Governance in the UNFCCC. It's failing, so why bother? Despite its lack of problem-solving accomplishments, governments continue to commit millions of dollars each year into addressing climate change within the United States Framework Convention on Climate Change, the UNFCCC. Why? Well, the pair of papers that you will hear in this second part of the presentation argues that governments continue to engage in international cooperation in this forum because the UNFCCC yields a host of strategic and normative benefits that go beyond greenhouse gas emissions and reductions alone. Dr. Jinnah's research focuses on changing dynamics of power and influence in global environmental politics with an empirical focus on biodiversity, climate change, and environmental intersections with international trade. Her recent book, Post-Treaty Politics, MIT Press, is the 2016 winner of the International Studies Association's Harold and Margaret Sprout Award for the best book in international environmental affairs.
That has not been officially announced yet to the ISA, so it can't be this room.
Didn't mean to leak it, but I'm glad I did. She is also the co-editor with Simon Nicholson of New Earth Politics, forthcoming from MIT Press in 2016. I assume that's public. Her work has been published in several peer-reviewed journals, including Global Environmental Politics and Science. She received her PhD in Environmental Science, Policy, and Management from the University of California, Berkeley, an MS in Environmental Studies from the University of Montana at Missoula, and a BA with Honors in Environmental Science from UC Berkeley. Simon Nicholson, Assistant Professor at the School of International Studies, is speaking on engineering the climate, the good, the bad, and the could be ugly. Dr. Nicholson will speak about a new research program led by his Forum for Climate Engineering Assessment, looking at the international governance of climate engineering research and potential deployment. Dr. Nicholson is the director of the Global Environmental Politics Program in the School of International Service and an assistant professor of international relations. His work focuses on global environmental governance, global food politics, and the politics of emerging technologies, including climate engineering or geoengineering technologies. He is the co-founder of the Forum for Climate Engineering Assessment, a scholarly initiative in the School of International Service. He received his PhD in International Relations from American University and his LLM for the University of Waikato in New Zealand. This panel has requested that you hold your burning and your probing questions until the end, so they have equal time to do their presentations. Thank you very much for coming today.
Thank you for that wonderful introduction, and thank you all for coming. I am really excited to talk to you a little bit about the physics of the ocean and how that, I was instructed to hold this microphone. Talk to you a little bit about the physics of the ocean and how that affects the climate on a variety of scales. So we're going to start by talking a little bit about these two maps that I've put up behind me, but before I get into that, I want to talk a little bit about my car. So here is my understanding of how my car works. I put gas in the tank, I turn the key, I push the pedal, and it goes. And I have to be honest with you. To date, this has proved to be a perfectly sufficient understanding for my purposes. But at some point in the future, I acknowledge, inevitably, I will put gas in the tank, I will turn the key, I will push the pedal, and the car's not going to go. And on that day, I might really wish I knew what a carburetor was. And I think that there's something similar to be said about our understanding of the climate. So we have had a huge effort as the climate science community, particularly the physical climate science community, over the last 30 or 40 years in developing global climate models. And we've done a really, really good job of building versions of the climate in our computers that do a good job of replicating the features of the climate that we observe around us. And we've gone way out of our way to make sure that the climate in the computer looks like the climate around us, because we wouldn't think it was a good climate model if we didn't. However, the way that we've done that is by making a lot of educated guesses, a lot of estimations, there's a lot of processes that are in there that we don't actually understand the physics of. We've just kind of jerry-rigged it so it produces something that looks like what we're looking for. And I think if we are comfortable that the climate that we want to study looks pretty much like the climate that we have, then that's a perfectly reasonable approach, just like my understanding of my car. As long as the thing is working, I don't really have to understand how exactly it's working. But we don't think that that's happening with the climate. We think the climate's changing. And given changed circumstances, we might actually want to understand how the thing works. And so that's kind of big picture why I think looking at ocean physics on a variety of different scales is really exciting and important and contributes to our climate change project. So I want to start, I'm going to talk to you a little bit about two different projects that are very much in this spirit. The first, it has to do with ocean mixing in canyons. So what we're looking at here, we've got two maps of the bottom of the Atlantic Ocean. So the only difference between them is that one of them has 1/12 of a degree resolution. So that's like 8 kilometer, 5 mile type resolution. And the other one has 1 degree resolution. So that's like 100 kilometers, 60 miles type resolution. And you can see that there's all kinds of really interesting things that are happening that you can see at 5 mile resolution that you can't see at 60 mile resolution. For example, the Atlantic has two different basins. It's got an eastern basin and a western basin, and they're separated by the mid-Atlantic ridge. And at this resolution, and the western basin has, as a general rule, has systematically heavier water than the eastern basin. And at this resolution, you can see that there are all these canyons through which this heavier water can squirt across from one side to the other, which might be an interesting thing. That's not possible at this resolution. This is the standard resolution for global climate models today. This is the Atlantic Ocean that our global climate models see. And this is much, much closer to the Atlantic Ocean that we actually have. And just to give you guys an idea of scale, all of these tiny little things we call ridge flank canyons that span the whole, there's hundreds of these, thousands of them in all, we see them in every ocean basin. There's thousands of them all over the world. Every single one of these little guys is bigger than the Grand Canyon. But that still means that every single one of them is too small to be seen by a global climate model. Now, why do we care? We care because of ocean mixing. And mixing doesn't sound that exciting, but when I talk about mixing, what I mean is the conversion of kinetic energy into potential energy. So this is like one of the most fundamental processes that happens in the ocean, and it is in fact half of the global circulation of the ocean. So you guys have probably seen a picture like this sometime before. This is the global overturning ocean circulation. And so what you can see is that in the North Atlantic and also down here by Antarctica, you have water gets really, really cold and really, really dense, and it sinks to the bottom. And then it kind of spreads out along the bottom of the ocean, and then it has to upwell back up. What goes down must come back up, because we have a closed circulation. We can't just keep sending water down forever. And mixing is basically the half of this circulation that is the coming back up. What we're doing is we're converting kinetic energy to potential energy, which is a fancy physics way of saying we are lifting things up. So the global overturning circulation, the half of it that's not the sinking, is mixing. And so we really, really care about how and where that mixing happens. And in fact, we care so much, and it makes such a big difference, because if we run a model for the Atlantic Ocean, and we look at the deep currents, so not the surface currents, which are mostly driven by the wind, but the currents below the surface, using this resolution or this resolution, and using different distributions of mixing, you can actually get your currents to change directions. Currents that used to go north start going south. Currents that used to go south start going west. It makes a really big difference. And so I have been doing some interesting work on trying to understand how exactly, what is the actual detailed physics of what is happening here. And what we find, so this is the results of some very idealized modeling. So we're just looking at a square canyon. But what we find is that, in fact, all of this mixing might be happening in a really, really thin layer that's just tens of meters thick that's at the bottom of the ocean. And so thinking about of these processes as kind of diffused over the whole basin is going to give us completely the wrong answer. So that's the first example of an interesting thing that we can learn by looking at the detailed physics of turbulence in the ocean. Another one, I'm going to talk just for a couple minutes about icebergs and what we can learn from icebergs about ocean circulation. So this is a picture of a colleague of mine from the Kangerlussuaq Fjord in Greenland, which I'm very jealous. This is from this year's field season, which I did not get to go on. But I'm actually more interested in icebergs that look like this. We call them ugly ducklings, and they're very dirty. They pick up a lot. They're literally dirty. They pick up dirt as the ice sheets are moving across Greenland, and then they fall in the ocean. And these guys have this lovely Hansel and Gretel quality, where as they go out into the ocean and as they melt, they drop all their little bits of dirt as they go. And the little bits of dirt are really easy to identify, because there is one and only one way to get a pebble into the middle of the ocean, and it's like this. There's no wind that can move a pebble into the middle of the ocean, and so unless you carry it there on a boat, this is how it happened. So icebergs and their contribution to, so understanding the dynamics behind these icebergs, of course, we care a lot about for a couple of reasons. One, for sea level rise. And so I've just thrown up a couple of figures here from the recent IPCC report. And all of this red area in Greenland is area where Greenland is losing mass. So it's taking water off the Greenland island and putting it in the water. Where this map comes from is actually like right at the front, like the science magic frontier. And I would love to tell you guys about it, but I don't have time. I'm supposed to take only 10 minutes. Feel free to ask me during the break, because it's awesome. But the point is that we have already substantial contributions from Greenland mass loss to sea level rise, and we expect much more in the future. And you guys also may have heard in the press, I have a quote here that I took from just a few months ago from the Washington Post, that melting ice sheets might in fact change ocean circulation, and that might change climate more generally. And so it turns out, yeah, so putting fresh water in here, we talked about dense water, water getting cold and dense and sinking. If you make the water really fresh, doesn't matter how cold it is, it's never going to sink. And so you can fundamentally change ocean circulation this way. And this is something that we care about a lot. And it turns out that giant quantities of icebergs have gone into, this has happened before. And it might help us to understand how the ocean actually works. So this is a map of going around looking on the ocean bottom for these pebbles. And all of these dots are places where we find pebbles that came from North America. And way, way beyond where we ever find icebergs today. And so, and it turns out they didn't come from Greenland. They came from here, the Laurentide ice sheet. And the punchline is that actually, so what we're looking at here, the dots are observations of pebbles, and the shading is where our research is modeling where we think the icebergs actually should go. And so people have used these observations to talk a lot about about how we might have these shutdowns of the overturning circulation, major changes to the ocean circulation. There may be historical examples of this, but in fact, that model is not consistent with the data that we have. So, in summary, understanding the climate means you have to understand how the ocean works at a lot of different scales. It's often very mysterious, but it's always fun. And if anyone has further questions, feel free to contact me.
I'm going to sit here so we can just switch. Okay. Okay, great. Thanks very much. Are you ready for me? Oh, is that okay? Is that okay? Okay. Great, thank you. I'm Sakina Jinnah, Assistant Professor at the School of International Service. Thanks so much, everyone, for coming to the inaugural session of the Ecollaborative Colloquium. We're really pleased to be launching it here, and thanks to the library for co-sponsoring it through the Research in Progress series as well. I'm going to talk today about a pair of papers that I'm working on that together broadly ask the question, why do governments continue to dump billions of dollars into UN climate politics when the UN climate system is failing to deliver repeatedly the necessary greenhouse gas emissions necessary to avoid what scientists tell us are needed to avoid dangerous anthropogenic impacts of climate change? I won't have time to talk about both papers in a lot of detail, so I'll focus on the top one. And then towards the end of my talk, I'll sort of point you in the direction of where that second piece picks up right as that first one leaves off. Because this is an interdisciplinary or multidisciplinary audience, let me just start with a really broad theoretical context and who I'm trying to talk to in this work. Broadly speaking, I'm working in the field of global governance, which is a subfield of IR, international relations. And I've thrown up one definition. There are many, many definitions of what global governance means. In short, global governance is interested in how states and, importantly, non-state actors cooperate to address problems that cross boundaries. So this might be political boundaries, I should say. So this could be climate change, it could also be security, it could be human rights, it's any issue of common concern across boundaries, political boundaries. And the field has by and large been concerned with what one of our colleagues at SIS, Amitav Acharya, terms supply-side questions. So these are questions about how does global governance institutions come to be, how do they perform, how effective are they at solving problems, how do they respond to the changing needs we see in the field. And far less attention has been paid to what Acharya deems demand-side questions, which are those that don't take the need for global governance for granted, but rather ask questions about if, why, and under what conditions does global governance actually need it? Under what conditions does it yield actual benefits? So in order to talk about this, I've sort of boxed demands into 3 baskets, right? This is a typology of demand. The first is pretty straightforward, so functional demand. So states may decide they want to participate in global governance because it yields problem-solving benefits, right? Because we can maybe reduce greenhouse gas emissions. Another box, and this is the one I'll focus on today, and it's really, it's maybe the most difficult to explain, but I'm going to try, is normative demands. And these say that states want to use global governance as a platform or a mechanism to hash out what is right or what should be, right? To reach common understanding on issues of common concern. And then the third box are strategic demands. And strategic demands are the kind of classical IR demands, which relate to states decide to cooperate internationally, they decide to engage in global governance because there's something in it for them, right? Because they want to enhance or increase their power or influence in global politics. In terms of functional demands for climate change, this is probably straightforward to most of us in the room. Climate change is a classic collective action problem, right? No state can solve climate change alone, acting alone. There's also, it's riddled with asymmetries, right? So put in brief, since I only have 10 minutes, those who contributed least to the problem historically are those that are going to suffer the most because of it and have the least capacity to adapt to it. So this demands international cooperation. So functionally, it's a no-brainer. Why are we cooperating internationally on climate change? But we're not meeting those demands, right? Functional demands are not being met pretty much any way you slice it. So we know that under the Kyoto Protocol's first commitment period that ended in 2012, at the end of 2012, most countries, or many countries anyways, have not met their targets. If we look to the commitments that states are putting on the table in anticipation of the big meeting in Paris at the end of next month, we also see pledges falling far short of the goals we've set for ourselves. So this graphic shows basically, we've set for ourselves a goal. We're trying to limit emissions to a 2-degree increase above pre-industrial levels. Business as usual would take us to about a 4.5-degree increase. And the proposals that were on the table as of October 21st only get us to a 3.5-degree increase, right? So we're seeing a big shortfall in terms of what's being pledged politically as we move into what we expect to be one of, if not the most important global climate negotiation for what's going to happen in the post-2020 period. So this is a big problem. And it raises the question, well, why do we bother? Why don't we just deal with this unilaterally or bilaterally, the way we've seen, for example, with China and the US and their bilateral arrangement? And not to say that the unilateral action and bilateral action isn't important. It is. But there's also really important reasons why states still choose and demand governance through the international system as well. And so what I argue in this pair of papers is that there's demands that are strategic, there's some that are normative, there's some that are functional that actually don't have to do with problem solving at all. And when I say problem solving, I mean reducing greenhouse gas emissions. And what I do is I categorize it by country type. So I create some big baskets of countries. Great powers, middle powers, emerging economies, developing economies, least developed countries, and then non-state actors as well. And I don't have time in the 5 minutes left to talk about all of those boxes, so I'm just going to cherry pick a couple. And then we can talk about some of the others in the Q&A if people are interested. So let me start with the US, because I thought it would be a nice juxtaposition with what Professor Fiorina is going to talk about in a few minutes. So despite generally low demand from the United States, as evidenced by our failure to even ratify the Kyoto Protocol, we still are a party to the Framework Convention, to the UNFCCC, the United Nations Framework Convention on Climate Change. And in that capacity, we've actually been pretty active in negotiating in that forum. We've actually demonstrated at least some level of demand for global governance in this forum. And the argument that I make in the first paper is that one major reason the US has been so engaged is because it sees this platform as a key place to negotiate a norm, a core norm of global governance, which is that of common but differentiated responsibilities, or CBDR. And CBDR is essentially about responsibility and how we allocate responsibility for climate change, for both solving the problem through emission reductions and for paying for adaptation or mitigation in poorer countries. Historically, under the first commitment period of the Kyoto Protocol, developed countries took on all the burden, right? And therefore, the vast majority of the cost. That developing countries were not given mandatory emission reduction requirements. And through the negotiations since that time, the US has had one key interest in spreading the wealth, right? Or I should say, spreading the responsibility. So in soliciting or lobbying for countries, especially emerging economies like India and China, to take on some sort of mitigation, some sort of cost responsibility as well. We can compare that to what we see in basic countries, or Brazil, South Africa, India, China, these emerging economies I'm talking about, who also have moderate to high demand for a very similar reason. They have functional demands related to access to international finance, but I don't have time to talk about that today. I'll focus on this second bullet here, which is also related to strategic and normative demands related to common but differentiated responsibilities. So as I mentioned, these countries did not have binding mitigation commitments under the first commitment period of the Kyoto Protocol. And so in part, what they're interested in doing and negotiating in this global forum is maintaining the status quo, or at least controlling the deviation from it, of this key norm in global politics, right? So it's about money and where the costs are going to be borne. I talk in a fair amount of detail about middle powers in the paper. I'm going to skip those today. Because I want to spend a little bit of time on non-governmental actors, because I actually think this is one of the most important reasons why we have global climate governance in the UN Forum. So on the one hand, we have private sector actors, and there's a lot of sort of anecdotal evidence here. This is not a systematic study of how the private sector views demand for global climate governance, but there is a fair amount of literature that talks about this in an anecdotal way. And what we start to see is some variation based on geography. So, for example, in the United States, there's evidence to support the argument that several private sector actors demand global governance, and they're interested in participating in global governance because they want to see the maintenance of a weak regime. On the EU side of the ocean, I guess, there's a kind of an opposite argument going on, where several EU private sector actors are interested in making sure that the actions they're taking regionally or domestically are actually being reflected in the global forum to maintain competitiveness concerns. An interesting piece of this is what's happening in some of the emerging economies, particularly Brazil, India, China, where you see many private sectors with high or moderately high demand for global climate governance. And this can largely be explained, I hypothesize in the paper, because many of these corporations, private sector actors, were the primary beneficiaries of market mechanisms under the first commitment period of the Kyoto Protocol. So about 85% of clean development mechanism revenue, which, if you're familiar with that, was one of the primary market mechanisms under the first commitment period of the Kyoto Protocol, went to these countries. So they were getting a lot of benefit through this global regime. In my last 30 seconds, let me just point you towards where that next paper I'm working on is going. One of the question that comes to the fore, at least for someone seeing this through a political science lens, is what explains variation? So why do some countries exhibit certain types of demands and other countries exhibit different types of demands? And so what my second paper does, and I go into a lot of detail about what these rationales might be in the paper in terms of hypothesizing about it, and the second paper really delves into one of those hypotheses and looks at leadership vacuums and how the leadership vacuum created by a failure of US and even a waning EU leadership on this issue in the global forum has created a place for emerging economies, in particular India and China, to take that space to identify themselves as leaders in global politics and to work out what that means. So that's the direction that second paper is going, and that's very much more a work in progress. But I'd be happy to talk more about that in the Q&A as well. And I'm also happy to take your questions via email or at the end.
Good afternoon, everybody. I'm impressed that we have such a nice, why isn't giving me my, okay, I'm not sure, oh, there it is, okay. Impressed that we have such a nice turnout on Friday afternoon. So I'm a political scientist by training, so I'll give you a bit of a political science perspective on some of these issues, and I'm focused mostly on trying to understand and explain domestic environmental politics. And this really brings together three areas of research that I've been doing. One is I've done some work mostly looking at the literature, empirical studies out there that tries to explain why some countries perform better environmentally than others do. So I'll bring in some of that and offer some explanations, I hope, for what's going on in the US. Second is I've been doing some work on this concept of the green economy. So the idea of the green economy is that you can find positive relationships among environmental, including climate action goals and economic goals, and that you can, there are ways to frame issues and also ways to pursue policy strategies that give you some better returns than if you sort of take the classic environment versus economy. And then the third stream is some work that I started with a couple of graduate students this summer, looking at state performance indicators of various kinds. So I'll give you a quick sampling of that, and I will try to answer the big questions that I raised in my title as I go. First, I want to give you a look at my favorite graphic. This is from my former employer, the U.S. Environmental Protection Agency. And I like to do this because it shows that it is possible to achieve what I would call absolute decoupling. So if you look at the top level, the drivers of environmental problems, economic growth in terms of GDP, vehicle miles traveled, population growth, and energy consumption, you see positives. So you see we had a very rapid economic growth. This begins in 1980 and takes us through 2014. So rapid economic growth, almost a doubling, 97% increase in vehicle miles traveled. So all those things that are going on. So what's going on below the line? That's minus 63%. Those are the aggregate emissions of 6 pervasive air pollutants that are regulated in the Clean Air Act, things like nitrogen oxides, sulfur oxides, particulates, and so on. So I always like to look at this because it says that public policy can make a difference, that in energy, public policy, until recently, our energy policy was cheap, affordable, available, reliable energy. The climate picture has changed that, as well as a number of other environmental issues. So that dynamic has changed pretty substantially. But it shows that public policy can have an effect, and perhaps we'll see some other effects as well. So just a little bit to sort of put that in perspective. So why do some countries do better environmentally than others? There are a variety of explanations. Some of the work says, well, what about institutions? Maybe parliamentary systems are better than separation of power systems because they're a little more nimble. You can get once you get a majority in government, you can move on that basis. Some people argue that, well, maybe it's the electoral system. Maybe when you have proportional representation where you're electing from multi-member constituencies, that people have to sort of move toward the middle, and there's a chance for small parties like Green parties in Germany, which has had an influence over the past couple of decades. So those kinds of factors. Some people look at economic factors. And there is a tendency, it varies by the problem and by the pollutant, but we do see a tendency that in the early stages of industrialization, countries tend to pollute a whole lot. And then at more advanced stages, a lot of emissions or pollution problems sort of decline. And some people say, oh, that's just an automatic relationship. As you get richer, you get better. Well, no. I think you have institutions, you have a demand for environmental quality, so a number of things going on. Some people point to social factors. I actually think that there's not a lot of empirical evidence on this. There's a little bit, but that economic and political inequality impair our ability to deal with collective action problems like climate change, like environmental problems in general. And actually, I think a lot of the dysfunctional politics we're seeing in our country these days, they're institutional factors, but I think a lot of it's related to increasing inequality and social mistrust, and that's making it more difficult to solve problems. And then some people would look at the distribution of political power, and in particular, how powerful are brown economic sectors, fossil fuels, industrial agriculture, and so on, relative to green sectors, renewable energy, and on down the list. So in terms of explaining what's happening in the US, I really don't see a lot of evidence that our separation of power systems is a major issue. It's more difficult to get policy change. Our system is designed that way. But also there are different points of access for people to affect change. If there's time later, I don't have time now, but we could talk about EPA's Clean Power Plan and how that came about. It's a great example of how separation of powers and federalism both work. I think federalism has been an advantage because we're seeing most of the innovative activity at the state level in this country, and I think that's where we're likely to see the most. We are, in political science terms, we are known as a pluralist system, contrasted with more cooperative corporatist systems like in Northern Europe and a number of other places. I think that's something of an issue. It's much more difficult to get agreement on common goals in our system than in other systems that have greater integrating and sort of consensus building capacities. So I think that's relevant. I've mentioned, I think inequality is an issue. I think our political culture is one that is very suspicious of the state in big terms. And so I think that always makes change difficult. Friends from Europe who would come here during the Affordable Care Act debates in 2009 said, you know, what's the big deal? Of course the government provides health care. Well, that's not our political culture, and so we see different points of view. I think an important factor in the U.S. is the power of the fossil fuel industry, which if you look at states that are moving on climate change, there are states that don't have a lot of fossil fuels. California, New England states. If you look at states that are now suing the EPA on the Clean Power Plan, they are led by the fossil fuel states. So that's sort of natural economic interest, natural politics. And to some degree, our institutions, I think, sort of enhance that effect because it empowers certain kinds of regional interests. So I think the explanation for why it's so difficult is a little bit institutions, a lot distribution of political power. I think there are some social and cultural factors as well. I'm just going to show these very quickly. This is the part of what the point I want to make today is that on climate change policy, like on many other issues, we are really two countries. So we have, I mean, California is up there with the most, you know, Germany, the most progressive European nations. It would fit right in. A lot of New England states are very, very progressive on energy efficiency. Even states that we might consider maybe less liberal, but we're seeing a lot of progress on renewable energy. So this is just very quickly a project where we looked for off-the-shelf sort of available information on environmental performance, and then we took measures and we normalized them by income, state income. So what we're trying to show is what level of environmental impact is involved for a state to generate a unit of income. And then we sort of make these radon charts. Reardon Frost, PhD student, works with me, did this work. So I could get more into detail on this, but for example, fertilizer use is an indicator of sort of the agricultural impacts on the environment. The CAP is criteria air pollutants, the major air pollutants regulated in the Clean Air Act, and so on. So you see New York, which is really pretty good on a lot of different indicators, something with water withdrawal, which we have to look into. Whereas my home state of Ohio is sort of more in the middle, more of a typical one. So eventually we want to generate these for all the states, and then we think we'll have a basis for promoting research by us or others trying to explain environmental performance at the state level. Just quickly on the point of tremendous variation among the states, this shows you the carbon intensity of state economies. So one being the sort of the most carbon efficient state in the country, and 50, Wyoming, being the least carbon efficient state in the country. And you see that there are just tremendous differences. And often these are presented on a per capita basis, which is useful, but this is on a sort of per $1 million of income basis. So we see a great variety, and we could certainly get into that. But if you look at the states that are low, they're fossil fuel states: Louisiana, North Dakota, West Virginia, and Wyoming, sort of confirming the theme that dependence on fossil fuels is a big deal. So what are the what progress has there been? What are the prospects in the U.S.? The last couple of years, we've actually seen some progress. I think President Obama, in his second term, has been a rock star on some of these issues, at least given the constraints he's facing. So we have major increases in fuel efficiency standards, more investments in renewables, pushing renewables on federal lands, EPA's Clean Power Plan, which sets a target of a 32% reduction in CO2 emissions from the electrical generating sector. However, at a national level, they're vulnerable. They're extra legislative. Congress has not been part of this, certainly vulnerable to political change and to legal action. And I think 26 states now are lined up to file lawsuits against the Clean Power Plan, and a bunch of other states are lining up on the other side. In terms of prospects, near-term congressional action is very unlikely. I think the composition of the House is sort of structural in the sense it's the way the districts are drawn, it's the way the population is distributed, so we're not going to see any change there. Senate is sort of hard to predict. Obviously, what happens in the White House is very important, but I don't see Congress in the next 2-3 election cycles really doing much. I think the leadership will continue to be at state and local levels, but I think we'll see tremendous variation in what states do. And I think ultimately it's going to depend on the balance of political power. So public opinion matters, but public opinion matters the extent it's transformed into mobilization and action, electoral outcomes, and I think that's a challenging area. So in terms of what I would call a green economic transition, I think we've seen it from this administration where they're really trying to sort of frame things in terms of the clean energy transition or a green energy transition. At a local level, we see a lot of cities implementing smart growth, sustainable growth. Mobilization of political power is very important. My own view, still waiting to be confirmed, but there are some hints of evidence, is that economic and political inequality are a big part of the problem right now and a big barrier to collective action at a domestic level. Effective international engagement, the international affects the domestic and the domestic affects the international. The fact that China made certain commitments and reached an agreement with the U.S. is very powerful because a common argument by opponents is that, well, the rest of the world isn't doing anything. And I think that can work different ways. And we also know that in terms of reducing the costs of dealing with climate change, they're less if countries cooperate. And then I think just continuing, as the Clean Power Plan does, empowering states to lead in this country. And at some point, perhaps the federal government will catch up. So, thank you.
It's on the desktop.
Okay, I'll find it. Close this one.
Yep. That's it right here.
Hi. I'm going to give kind of a research design and program design talk. I'm talking about a new 3-year funded project that we have with my Forum for Climate Engineering Assessment, which is a group based in the School of International Service. But before I do that, let me just acknowledge that this is the first ever Ecollaborative event on the campus. Right? And it was set up by Annie and Sakina, and who else was in the team that put this together?
Angela.
Thank you. I mean, this is fantastic. The Ecollaborative is an effort that we started, a small group of us got together and put together a half-day retreat for environment faculty and staff from across the campus last semester. Out of a recognition that we have a world-class faculty on our campus who are doing extraordinary things, but as a campus we don't yet have a world-class profile around environmental issues. And so the Ecollaborative is an effort to just bring us together and to get to know each other a bit better and to find out more about our research, and this Coloquiium series is going to be an important part of that. So thanks for putting this together. This is the first in a series of, I think, 6 you have planned over the next 2 semesters, and so keep an eye out for more about that. The next stage in the Ecollaborative effort is to talk about shared research interests. And so that's something we all have to get our heads together around. The Provost's office is offering funding for Startup 2030 related initiatives. Ours fits into that umbrella. And so we have to start putting our heads together about how we're going to move this forward. So speak to Sakina, speak to these other folks, speak to me, Kiho, about what we can do together. So thanks for being here for this first event. So the Forum for Climate Engineering Assessment is a small research programming outfit that we put together in the School of International Service. It's looking at the politics and social implications around this emerging conversation about climate engineering or geoengineering responses to climate change. Is that geoengineering, is this a term that's familiar to most of you? So very quickly, climate engineering is kind of an umbrella term for a set of imagined technological responses, big technological responses to climate change. We're not talking about renewable energy, kind of energy transformation in the way that Dan was. We're not talking about building seawalls, for instance, as an adaptation strategy. This is a whole different class of technological options. And so what we're looking to do in the forum is to try and make sense of this conversation and to act as an honest broker within the conversation so that folks can make this talk more robust and more inclusive. So our 3-year funded project is looking particularly at international governance, and Michael Thompson, who's here on the front row, is the manager of the grant that we have. And so I'm going to talk a little about what this conversation is and what the international governance dimensions are, and what we're looking to do as a group to start to wrestle with and address some of these questions. So I should say from the outset that any talk of trying to engineer the climate was for a long time taboo. Nobody spoke about this stuff. Geoengineering was basically off limits. But that started to change largely because there's a growing set of people within the scientific community who are getting pretty frightened about the sorts of graphs that you saw from Sakina. If we're on track on a business as usual pathway, as this graph shows, that top line is business as usual, taking us to between 4 and 6 degrees, perhaps higher. Don't worry about the number so much as the magnitude. 4 to 6 degrees or higher of warming above pre-industrial levels by the end of the century, then that's not a good place to be. Really robust mitigation efforts, the sorts of things that you might see if Paris just goes really well, and all of the activities that might follow. Some of the figures coming out now suggest we might be on track for 2.7 to 3.4 degrees of warming if Paris is a real success. But even that is potentially catastrophic in terms of the sort of climate risk that it puts the world in the face of, and the implications of that risk for the most vulnerable populations on the planet are stark and quite frightening. And so what does one do in the face of that? You can mitigate further, perhaps. You can have adaptation to try and account for some of the problems and suffering, but are there other options on the table? That becomes the starting point for a conversation about these large-scale technological responses. Now, I should be clear, the forum is not an advocate for climate engineering. That's not what we do. What we try to do is make sure that the right voices are being heard and the right questions are being asked. So don't read this as a pitch for climate engineering. I'm just starting a conversation. So the sorts of options that folks are talking about tend to fit into 2 different buckets. On the one hand, removing large amounts of carbon from the atmosphere can be considered a way to augment traditional mitigation activities. And some folks put these together as kind of a geoengineering response, and they call it carbon dioxide removal. So planting a bunch of trees, using biochar as a fertilizer and a way to capture carbon in the soil, perhaps doing some stuff with the oceans. These all become potential ways to draw carbon out of the atmosphere and to hold it in long-term storage or to put it to beneficial use. Okay? And if we go back to this chart here, that would be a way to bend the mitigation curve further, to start bringing enough greenhouse gases out of the atmosphere that you can start to potentially decrease long-term average temperature increase. Good idea. But very costly, only works over the long term, very difficult to scale the sorts of technological options that are being considered. And so when folks talk about climate engineering, what they typically mean is this next bucket of responses, so-called solar radiation management responses. Solar radiation management responses would cool the planet, would turn down global average temperatures by reflecting some amount of incoming solar radiation before it can be captured by those greenhouse gases that are in the atmosphere. And so basically the idea is if you can increase the so-called albedo, the reflectivity of any part of Earth's systems, models suggest that if you reflect something like 1.8% of incoming solar radiation, then you could take planetary global average temperatures back to pre-industrial levels. Turn down the sun, decrease the temperature, right? Straightforward. but tricky from an engineering standpoint and also from all of the implications of this move, right? And so at ground level, you could imagine more reflective crops that would put solar radiation back into space before it turns into the long wave form that's captured by greenhouse gases. The major strategies that folks are talking about are either marine cloud brightening, that is increasing the reflectivity of marine clouds by introducing saltwater droplets from the oceans up into the cloud layer. There's a major program which has just gotten started on the west coast of the United States looking at this technological option. And then the idea that's receiving the most play in the domestic and international conversation around climate engineering is so-called stratospheric aerosol injection, SAI, stratospheric aerosol injection. The idea is if you introduce particles, probably sulfur dioxide particles, into the stratospheric layer, then this would mimic what happens when volcanoes erupt and spew sulfur into the atmosphere. The sulfur layer, these particles are reflective, so you could shoot incoming solar radiation back into space if you kept that sulfate shield in place and intact. Okay? So these are the sorts of ideas that are being tossed around. The first graph that I showed you suggests that these sorts of ideas are worth considering on their face, given the magnitude of the challenge that the international community is faced with to address all of the suffering and other problems that go along with increased global average temperatures. But there are big questions. And some of these questions are governance questions. And so in prior work, what I've tried to do is to pass out the potential challenges or risks that are attached to this conversation around solar radiation management in particular. And the way that some of us have looked at it is that there are clear material or physical downsides that becomes the first category. If you move in this direction, well, you're interfering with the climate system, so that might impact weather systems. And so some models suggest that if you introduce large amounts of sulfate into the stratosphere for an extended period, then it might, for instance, impact, say, the monsoon rains in India. And so how do you start to make sense of these sorts of challenges and potential trade-offs? Right, so there are a whole set of material and physical questions to be asked, and the physical science community is doing a pretty good job through modeling and are planning, potentially, open-air testing of certain technologies to help us understand some of these questions, right? So that's where things stand at the moment. The second category of potential challenge and risk are political challenges, and that's where the group that we have here in the school starts to step in. Who gets to decide whether this is a good idea? Who gets to decide if you moved in this direction where the benefits should accrue, right? Who should be protected, who not by a sulfate shield? And so in the 3-year funded project that we have, we're looking at the various governance questions that are tied to a move towards climate engineering. Here's the kind of the research and progress piece of this. So what we're doing at the moment is that we're developing the multi-year program by which we're going to look at these questions. And we have enough funding that what we're looking to do is to bring together a working group of high-level academics from different parts of the world to sit with us for a couple of different workshops over the next calendar year to kind of workshop through the questions surrounding governance. What we want to do is bring together folks from a number of different disciplines, and each of these people we're targeting because they have not yet been a part of the climate engineering conversation. The reason that we're looking to do it that way is because the current group of folks who are looking at climate engineering governance have had lots of good meetings and done lots of good work, but the conversation's getting a bit insular. And we want to bring some new perspectives in, add some new life to it, and try and move the conversation in some new directions. And so the first major meeting of this group is going to take place here on the AU campus in March. Pieces of that meeting, we're still in the planning stages, but pieces of it will likely be public. Can I say that? We don't know which pieces, but some of these pieces will be public, and you'll receive lots of advance notice about what we're looking to do with this programming. But the sorts of questions that we'll throw to this group start from the very broad. Can you take something like solar radiation management and actually govern it? Because that's an open question, it turns out, among the group of people who are looking at the governance of climate engineering. It's not clear that this stuff is governable because, unlike the collective action problem of getting countries together to tackle greenhouse gas emissions, if you want to spray sulfate particles into the stratosphere at large enough a quantity to do something about incoming solar radiation, you don't need all of the world to make that decision. One country could potentially develop the infrastructure it requires to do this all by itself. The United States or China or Brazil or India might potentially decide to go it alone. And so in that sort of, with that sort of characteristic, is it even possible to put together international regimes or international mechanisms by which you would govern research and potential deployment in this area? It's an open question. Another big question for the community, for folks looking at climate engineering, is do you need governance in place before research proceeds, or do you let mechanisms of governance bubble up from the research? And so at the moment there are some research groups around the country, most notably a research group at Harvard University, that is talking about doing some stratospheric aerosol release at a very small scale, just to do some basic open-air testing of delivery mechanisms and the reflectivity of certain particle sizes. Important questions and important kind of basic science if you want to understand whether this is actually an option. But they're not sure whether they're allowed to do it under existing environmental laws in the United States. This is governed by environmental impact assessment laws that we have, by the Clean Air Act. What can you do with domestic regulation? And do they want to start with that form of testing before international regulations and laws are in place for fear that it's going to be taken as a move by the United States to grab hold of this research agenda and drive it before the rest of the world can have a say, right? Or the other argument is, do you just go ahead and do this sort of basic research, and then the scientific community itself decides how best to govern these kind of forms of research, and then that bubbles up to inform international governance conversations? Open questions. We don't have good answers yet. Another open question, can you use existing mechanisms? Does the UN Framework Convention become a place where you can have conversations around climate engineering governance? Can you talk about it under other existing international regimes, that is institutions and laws that are in place to tackle various environmental and other questions? Or do you need some new agreement at the international level at a time when there is no real appetite for international cooperation around this issue or many others? And then a final piece of this, whose voices should be a part of this conversation? Another project that we're developing in consultation with a number of different bodies in the United States and abroad is around public consultation for this set of emerging technologies. And so how do you get the voices of democratic publics from around the world involved in this? Is it possible? Does it matter? Who should have a say? This is tricky stuff. And so often when I'm giving talks on this, I use a quote from physicist Freeman Dyson, and I pull this quote out of a book by David Keith, who's a leading proponent of research into solar radiation management technologies. If you stand in the way of this, or if you push it forward, then there's a lot at stake. And so again, the Forum for Climate Engineering Assessment has been set up to make sure that this is a more robust and inclusive conversation, and we're always looking for collaboration and input. So to find out more, take a look at our website, ceassessment.org. That'll take you to the current site that we have. It's being revamped at the moment, so fish around, and my email address in case you'd like to get in touch. Thanks again. Sure.
I'm glad we picked an easy topic.
So we have about 15 minutes for questions. The library has generously hosted a reception for us and have asked that we kind of finish things up by 5:10, 5:15 so that we can enjoy that. So thanks very much for that. So I thought we'd take maybe a few questions and then the panelists can sort of address them. We would particularly, in the spirit of interdisciplinary exchange, welcome questions that cut across the different topics as a special challenge, but we'll take, speaker-specific questions as well. So,
I have a question for Sakina and Dan. There's a long-standing debate within history of whether historical events are driven by great leaders or if there are actual historical undercurrents that pull societies along regardless of who the leadership is. So insofar as climate is concerned, it seems to me that there is a very strong undercurrent. If you follow the science, you cannot ignore it. So then it turns to the leadership question. And it seems to me that Xi Jinping, if he feels secure domestically, he is one who likes bold moves, and he could exert leadership in this area. That might be quite significant. The other is we see anti-leadership. And in this country, you have the Koch brothers who were involved in obfuscating and helping to elect people to defeat the climate agenda. And then maybe the most important thing is to overturn Citizens United. So what's your thinking about this?
First.
Yes. In terms of how big historical change happens, I think historically you look at events lead you in a certain direction, and then you need leaders who will capitalize on those events and certainly lead. So that's, I guess, the short answer to that. The problem with something like climate change is it has to be action on a global level. It starts at a national level, and a certain number of key countries are very important, but it requires leadership at both levels and sort of collective leadership. And that's why I've always thought, I mean, the multi-party approach and getting all the countries together is important, but if you get the US and China and the European Union together and you can move in some pretty strong directions and get some of the other countries together, you're dealing with 2/3 of the emissions, so that will sort of drive the solutions. On the domestic politics, the Koch brothers are one example, but opponents of climate action have done a very effective job of raising doubt, of sort of obscuring the issue enough so that a lot of people don't know what to think. And we know the climate has become so politicized that people sort of tend to go with opinion leaders. So you can hear about the science, but then an opinion leader, if you identify with them, tells you one thing, or you hear about some weakness in the climate research and therefore raise doubt. So they've done a very effective job of raising enough doubt to make it difficult to build a political consensus. And I think that's one of the big barriers to getting solutions here. And yeah, Citizens United, campaign financing, districting, there are a number of structural issues in our democracy right now that are major barriers to any kind of collective action, whether it's healthcare, education, climate change, pick the issue. I think we see it almost across the board.
Yeah, so leadership in global climate politics there's been a dearth of it, absolutely. I mean, the closest we've seen is leadership from the European Union, in particular Germany, and there's a fair amount of consensus that that's starting to wane. And I think in part this is the rationale or the motivation for the second project that I want to work on this topic, which is to say, well, where else can we find leadership on this issue, at least when we're talking about states? And I think that there's a really promising and important pool of leadership potential in emerging economies like India and China, who are not only interested in establishing themselves as leaders for the sake of climate change per se, but because they're interested in establishing themselves as leaders in world politics, right? So this is a geopolitical issue as much as it is a climate issue. And so the best answer I can give you on whether it'll be important is stay tuned, and maybe in about 6 months when I finish writing that paper, I'll have a better answer for you on that. But I can say that I think it's an important thing to be thinking about and could potentially have some important catalyzing effect on what we see in terms of global leadership on climate politics.
If I may follow up on that,
Sure.
what I wanted to lead to was, what's your opinion about where Narendra Modi fits in on this?
My personal opinion?
Yeah.
Yeah, so the question was, where does Modi fit in on this, the leader of India? I don't really deal with that level of politics, so I'm not an expert on Indian climate politics, so I'm sort of hesitant to offer an opinion on that. I don't know if Dan?
Yeah, because India's been kind of a laggard at this point.
Yeah. I don't know if anybody knows in particular.
Yeah. Thanks. Maybe can you identify yourself? I forgot to say before you ask your question.
Sure. I'm Richard Jordan. I chaired the 2007 NGO conference at the United Nations called Climate Change, How It Impacts Us All. My comment really follows, I think, your comment, Dr. Jinnah, and that the exercise of soft power by China is extremely important. If you look at what I would call a GANGO, not a GONGO, a government-organized NGO, but a government-approved NGO like the China Energy Fund Committee, which just gave $1 million prize at the United Nations on solar energy, I think we're looking at the exercise of soft power by China in many different ways. So I perhaps could bilaterally discuss this further with you after, but I think,
sure,
again, we're looking at Chinese one belt, one road, work with China, and China will pull the whole world along with it. So I think that we have to look at also.
Yeah, that's an interesting point. I'll just offer one comment. so that others have a chance to talk. But one really interesting thing we're seeing with respect to Chinese leadership in this regard is South-South finance. So China has been very active in beginning to fund least developed countries, small island developing states, to help with adaptation and mitigation in this realm. And that's just one indicator of where we're seeing both leadership and soft power in some sense being exerted. So thanks for the comment. I guess I have a question for, oh no, go ahead. I didn't see another one, so I was going to take it.
I was just going to say...
Can you introduce yourself?
Well, my name is Natalia Penton. I'm a senior in SAS, and I actually take Professor Gearing's class. And I wanted to give Professor Dell the opportunity to explain what you were talking about land loss in...
Oh, mass loss in... Oh, sure. Okay, so as I said, right on the science magic frontier. So the way that we have a lot of ways of determining how much mass is going from the ice sheets in Greenland and Antarctica into the ocean. And this is, we think, going to be the dominant contributor to sea level rise in the coming century. And so, just in the last decade, we've gotten a new tool, which is the GRACE satellite mission. And GRACE is, it's 2 satellites. And, okay, I don't know how to explain this and hold a microphone at the same time. So you got 2 satellites, and they orbit the Earth together. And they have a very sensitive set of lasers that go between them and reflect back and forth. And they're able to time down to a teeny, teeny, tiny fraction of a second how long it takes for the lasers to go back and forth, and so exactly how far away these 2 satellites are. And what happens is, as the satellites come over Greenland, the first one, Greenland, all of this ice on Greenland weighs an enormous amount. So you get a little bit of extra gravity. Even compared to the Earth, the ice weighs a lot. And so you get a little extra gravity, so the 2 satellites come along, and the first one, the closer one to Greenland, gets pulled down by this little extra gravity and gets pulled away from the other one. And so the distance increases. And then as it's moving over Greenland, and as the next one comes over Greenland, it gets pulled down, and so they get closer again. And then as they move away from Greenland, they do the same thing in reverse. And so by taking, and they go around and around and around, and they do this, and they go one line and then a little farther north or a little farther south, and they move, and you can put all this information together using very sophisticated computer algorithms, and you can basically weigh the ice sheets as you go, and you can make maps at about 100 to sort of, depending on how frequently you want to make your map. Sometimes it's 100 kilometers, sometimes it's 500 kilometers, but like I said, you can weigh the ice sheets just using these 2 satellites getting closer and farther apart, which I think is just astonishing, that we actually are able to pull that off. And that is at this point, the GRACE satellite missions are the most reliable way that we have for measuring how much water is coming off the continents and going into the ocean, and it's accelerating.
Is that only being measured in Greenland, or is it in other glacial regions?
No, so we can do, actually, so you can use GRACE with any movement of water. So you can, other things that we can measure with GRACE. So you have the mass of ice in Greenland, the mass of ice in Antarctica, the amount of groundwater underneath the state of California. You can watch us pump out all of the groundwater and dump it into the ocean. And groundwater in other places, the loss of, the melting of glaciers in the Himalaya and in the Andes. Everywhere around the Earth that large masses of water are being moved, we can monitor that with GRACE.
Thank you.
Emmanuel?
Hi, my name is Emmanuel. I'm in the Global Environmental Politics Master Program. I have a question for Professor Daniel, I think. I understand that the climate debate in the US really depends on some internal domestic politics and realities. But assuming that maybe in December that we have a role which is supposed to hold countries accountable for their commitment, and what might be like the what might the US be ready for if we have to talk about accountability? And when I talk about accountability, I mean sanctions. What might the US be ready for under the UNFCCC?
Sanctions for?
For a failure to meet your IBC budget.
Oh.
Thanks.
Well, Sakina can answer this better in terms of what the international community can do about any agreement. I mean, I think the U.S. is going to the Paris negotiations with the best story it's had probably yet, mainly because of the administration's leadership. The opponents, though, Senator Inhofe, for example, who chairs the Senate Environment and Public Works Committee, has been actively lobbying to undermine the administration positions, sort of communicating with people from other countries that, well, the Congress isn't behind this, and a change in leadership, the U.S. wouldn't be reliable, so don't count on it. So we're seeing activities to sort of undermine that position. But in terms of what the sanctions would be, I don't know. I'll let Sakina respond to that.
There won't be sanctions. The U.S. is not going to accept sanctions for anything beyond what we see in the trade regime. So, I think we probably have time for one more question or comment. Yep.
We kind of currently politically have precedent for a non-ownership of large tracts of land, be that the middle of the ocean, be that Antarctica, be that the moon. So I guess this is a question for everyone, maybe politically or scientifically, but specifically for Dr. Nicholson. Since we don't really have any precedent for having the political will or even the political legality to mess with the stratosphere, I guess. Just like you can't do weird stuff on Antarctica because no one owns it. So is there any kind of precedent for owning or a part of the stratosphere? Is the United States all the way up? We have clear ownership, or do we just have, once you break out of like aviation level altitudes, it's kind of like generally it's our stratosphere and not Europe's or Asia's or US's? I guess is there a precedent for that, or is that the new scientific frontier and a new political frontier?
So any large-scale atmospheric solar radiation management program would be, by its nature, transnational. It would be hard to keep sulfate aerosols completely within a country's borders, and so even if the United States could claim ownership all the way up to outer space, those particles would drift. And so you would need some sort of international regime or international cooperation. And we do have, at the international level, lots of different mechanisms and regimes for trying to coordinate activities within the global commons. So that the Framework Convention, for instance, about polluting into the global commons is one example of that. In terms of weather modification, the United States and other countries have long had weather modification programs, some which the United States tried to militarize back around the Vietnam War. And so we have this convention at the international level about the non-militarized uses of weather modification technologies, which has been on the books since the 1960s, 1967 or so. And so the world community has already come together to try and work out what you can do in that kind of atmospheric space with the deployment of technologies that might alter weather patterns. And so it's not too big a leap to imagine the world could coordinate around the development of these sorts of technologies, except that it's really, really, really hard to get anything done at the international level around anything at the moment. And so to come up with a new regime, or to put it into the Framework Convention at a time when there's so much at stake around just the basic mitigation conversation, the pathway forward is not clear for the world to come together to answer these sorts of questions.
Last question.
I was just going to follow up on it. What's the governance structure around satellites? Does that apply in any way?
I don't know.
There is actually a precedent. The nations of the world ban testing in the upper atmosphere in space. So that could be the precedent for this. I mean, if you set off a nuclear weapon really high up in the atmosphere, you'll fry all the electronics on the surface through something called electromagnetic pulse. So there is this very strong precedent. We will not do this.
Yeah, I don't know enough to have a good answer.
Great. So I think we're out of time. Nancy, did you want to say something at the end?
I want to thank all of you for the panel for putting on this really engaging, even to the non-scientists in the room, to be able to understand. And thank all of the students and your co-faculty members who have come today. This is a really fabulous turnout for one of these events. And the provost wanted to be here, but he had an unavoidable conflict. And I will be sending him a message to let him know what he missed. Because it's this kind of engagement for which AU 2030 was invented. And you guys represent a really fine model. Thank you.
And thanks again to the library. Just a reminder to faculty who are part of the collaborative, we have our first Ecollaborative faculty happy hour today as well, at just following this event at 5:30 at Chef Jeff's. So